We have completed up till now the first 5 chapters in science. Now we move further and start with the next chapter, that is the sixth chapter about physical and chemical changes. So, in our day to day life, we come across many changes. Some we notice it and some we don't notice it because we are not aware that that's a physical change or that's a chemical change. For example, when you dissolve sugar in water to make a cold drink, so that is a physical change because the cubes of sugar are being converted to liquid form and is getting mixed with the water. Similarly, the changing of milk into curd is also a physical change in which the milk is converted to curd because the milk gets sour. Now, the next example you all must have done in at many times, right? For stretching, like stretching the rubber. So when you stretch a rubber, the shape of the rubber band changes, and similarly, when you leave the rubber band, you what happens? It comes back to its normal position. So that also shows you some physical change. Now there are two types of changes. One is the physical and the other is the chemical change. So first we will look into the physical changes. So in activity 6.1, they have said that you have to take a paper. They have shown in picture also in figure 6.1. You have to take a paper, cut it into 4 big pieces. And what you have to do, you have to take one piece from this and cut it into 4 different pieces. So you can see that the size of the different papers is different, which you have cut it from a big paper. So what is happening? The size of that big paper is changing to different sizes. First, it changed to this size, then it changed to this size again. So, which is a physical property, that size of the paper is changing. That physical change they are trying to show you through this activity. Now, the activity 2 says that you have to take a chalk piece, convert it into a powder form, or crush it into a powder form, then put water in that chalk dust and make it into a paste. Then again roll a chalk piece of chalk from that paste and then let it dry for some time. So after that, what you see, you will recover the chalk, but it will not be in the same size and shape as it was before. So there's a physical change in the shape and size of the chalk. The next activity shows you that you have to take some ice in a glass or a plastic tumbler, put it in the sun for some time. So, what happens? The ice starts to melt. So, now you have a mixture of ice and water. Now, this mixture of water that you have in your glass, you have to keep this glass, which has ice and water mixture, in a mixture of ice and common salt. So what will happen, that the ice will not melt as fast as it melts when you have not kept in a mixture of ice and common salt. Why? Because ice and common salt is called as a freezing mixture. It does not allow the the increase the temperature of the ice, because when the temperature increases, what happens? The ice starts to melt. So it maintains the temperature of the ice and does not allow the ice to melt. Okay, so this you have to remember, that ice plus common salt mixture is called as the freezing mixture. Okay, now the next activity 6.4, in that what you have to do is you have to boil some water in a container. So when you see that the steam is rising out of the water, you have to put a lid on top of the steam. So what happens? The steam touches the cold lid and then then what happens is it gets converted into water droplets. So this process of converting the steam into water droplets is called as condensation. Okay, so that is also physical change. The steam is converting into water droplets. Okay, so that is also one type of physical change. Now the next physical change is in activity 6.5. You have to use a hack saw blade with a pair of tongs. Keep the tip of the free end of the blade on the gas stove and you will see that the color of the tip of the blade changes to red in color. Then when you remove it from the gas flame, it again comes back to its original color. So why this happens? Because uh, it got heated up, and that's why the metal got changed to that color when it got heated up, and then when it cools down, it comes back to its original color. So up till now we studied different activities in which there was physical change. Okay. So in activity 6.1 and 6.2, we saw that the paper and the piece of chalk underwent changes in size. As I said, the size of the paper changed. Similarly, the size of the chalk also changed. In activities 6.3 and 6.4, what happened? Water changes state from solid to liquid or from gas to liquid. In activity 6.3, the ice was melting slowly, so ice was being converting to from solid to liquid. And in this activity 6.4, what was happening? The steam that is coming out of the boiling water, that was being converted into liquid. In activity 6.5, what we saw, the hacksaw blade changed color on heating. Yes. So its which property? Color property was getting changed. So properties such as shape, size, color, and state. State means solid to liquid, liquid to gas. That is called as a state of a substance are called its physical properties. So shape, size, color, and state are called the physical properties, and a change in these physical properties is called as a physical change. For example, in the all activity we saw that in one activity the shape was changing, in one activity the size was changing, in one activity the color was changing, and in the last activity, in some activities, the state of the material was, or the substance was changing. So when there is a change in the physical properties of any substance, it is called as a physical change. A physical change is generally reversible. So they are saying that a physical change can be reversed. In such a change, no new substance is formed. So in this physical change, we saw that no new substance is formed, nothing new, right? Water was there, water was boiling, it was converting to steam, again it converted to water only. There was no change in the substance. The substance remains the same. So now, as we completed here the physical changes, what are the physical properties, and which physical properties change in a physical change? When a substance undergo a change, what are the physical changes? Now let us go to the chemical change. A change with which you are quite familiar is the rusting of iron. Yes, everybody must have seen rusting of iron. Where you must have seen? That you must have seen in your bicycles, right? When you don't use your bicycles for a long time, or your bicycles become very old, okay? So what happens? It starts to rust. You can see a red powder material starts to form on the metal piece of the bicycle. So if you leave a piece of iron in the open for some time, it acquires a film of brownish substance. Yes, that rust is somewhat brown and reddish color. Yes, this substance is called rust, and the process is called as rusting. Okay, so the conversion of that metal into this brownish substance, brownish dust like substance, is called as rusting, and that brownish dust is called as rust. You must have seen where these things, examples of rusting you can give: iron gates of parks, farmlands, iron benches that are kept in lawns and gardens. Almost every article of iron, any substance or any material that is made up of metal, iron, okay, iron metal, that gets rusted. When it kept in the open, gets rusted. At home you must have seen shovels and spades which are used to dig the soil, okay, that are called as shovels and spades, getting rusted when exposed to. So this, in this picture they have shown some examples of old objects, okay, which get rusted, on which that brownish substance starts to form when they get exposed to air for a longer time and they are not being used and cleaned. Okay, yeah. in the atmosphere for some time. In the kitchen, a wet iron pan often gets rusted if left in that state for some time. Rust is not iron, it is different from iron on which it gets deposited. Okay, so rust is not any type of iron, it is some other material which gets deposited on that iron material. Okay, now let us consider a few more changes where new substances are formed. So up till now saw that nothing new was formed. In the physical changes, nothing new was formed. Only size, shape, color, such things of the such properties of the object were changing. So now we are going to see the things where a new substance is formed because of that chemical change. Yes, up till now we saw that how the rusting of iron takes place, in which on the metal iron some powdered form of substance is formed which is called as rust, which is brownish in color. Okay, so new substance is formed on the metal because of the chemical reaction of the metal with the air that contains oxygen. Okay, now, similarly, we'll look into different things which changes because of the chemical reaction that happens between those two substances. Now, the first activity they have given, get a small piece of thin strip of or ribbon of magnesium. Clean its tip with sandpaper. Sandpaper is a rough paper which you must have seen when a house is painted. They rub it with a paper that is rough, so that all the paint that is applied on the wall gets cleaned off properly. And they, when they paint it again, it does not create a problem, and that double layers don't form up. Okay, so that is a sandpaper. So clean it properly with the sandpaper. Then bring the tip near a candle flame. Okay, so what happens when that ribbon starts to burn, it burns with a brilliant white light. Okay, and that light is very harmful for your eyes, so you should not look directly on that light. So when it is completely burnt, when the whole ribbon gets burnt completely, it leaves a powdery ash, a grayish type of powder. Okay, now what we have to do is, uh, the ash we have to mix it with water. So before that, they have given you the equation, a magnesium, that is Mg, plus oxygen, that is O2. These are the chemical name, Mg and O2. Okay, magnesium plus oxygen gives us magnesium oxide, which is MgO. Okay, so this reaction, magnesium and oxygen chemical reaction, gives us magnesium oxide. Now what we have to do, we have to collect that powdery ash and mix it with small amount of water, stir the mixture well, and then you have to put some drop of this solution on red litmus paper and blue litmus paper. So what you will see that the red litmus paper will turn to blue. Why? Because this solution is basic. How it becomes basic? See, magnesium oxide, okay, that ash was having magnesium oxide because it's converted, because it was a combination of what? Magnesium plus oxygen. That reaction produced magnesium oxide, and that magnesium oxide ash, that powder, was mixed with water, and these two, when reacted with each other, they form magnesium hydroxide. And magnesium hydroxide is a base. So what does the base do? It converts the red litmus paper to blue. So what will happen? It will magnesium hydroxide. So from this we understand that magnesium hydroxide is a base, and it is the new substance, magnesium oxide and magnesium hydroxide. These are the two new substances which are formed when a magnesium ribbon is burnt. So in this chemical change, two new substances are formed. So these are very important for you to, this equation and these products are very important for you to remember. Now we'll go to the next one. We have to take copper sulfate. These all chemicals you'll only find in the chemistry lab. Okay, it is not available at your home. So we have to take copper sulfate in about half a cup of water in a glass. So you have to dissolve a teaspoonful of copper sulfate solution in a half cup of water. Now add a few drops of dilute sulfuric acid to the solution. You should get a blue color solution. So you'll get such solution when you mix copper sulfate with water and then add some sulfuric acid into it. Now we have to keep a small amount of that sample in a different small bottle or a different small container, and then in the other in the other quantity, more quantity solution, what we have to do, we have to put a nail, okay, khili, a nail or a shaving blade. You must all have seen this such type of blades, okay. Any one thing you have to put it, keep in that blue color liquid for half an hour. So after that you will see that blue color liquid will turn to green, and there will be some brownish type of material on the blade. Okay, so here also two substances are formed, that brownish, that happens because there is copper, because that was a copper sulfate solution, right? So copper got deposited on this metal. Okay, so the what happens is, compare it to the color of the sample. So after half an hour, when you see what happens, from blue to green, it is due to the formation of iron sulfate. So copper sulfate solution plus iron gives us, because if we put that blade, that iron blade, so that iron blade is made up of iron. So copper sulfate solution plus iron, when they react with each other, they give iron sulfate solution and plus copper deposits. So copper gets separated and they give a solution of iron sulfate. That copper gets deposited on that blade piece, and that's why that blade piece looks like brown. Okay, so these are the two products of the copper sulfate solution plus iron, that is iron sulfate and copper. Now next we have to take a teaspoonful of vinegar. Okay, add a pinch of baking soda into it. You know that when you add baking soda into water or vinegar type of thing, you must see bubbles coming out. Yes, now pass this, that gas, that bubbles is coming out, they are saying that you have to pass it through freshly prepared lime water. Okay, so when you pass it through the lime water, what will happen is, the change in the test tube is as follows. It will what the changes that you notice are due to the reaction between copper sulfate and iron sulfate, that is of this iron, this they are explaining this activity. Yes, the and the change in the test tube is a vinegar plus baking soda. It gives, baking soda's name is sodium hydrogen carbonate, that gives you carbon dioxide and other substances. So when vinegar and baking soda react with each other, you get carbon dioxide and other substance. The reaction between carbon dioxide and lime water. So when you pass that carbon dioxide to lime water, what happens? It forms calcium carbonates. What does it form? Carbon dioxide plus lime water forms calcium carbonate and water, which makes lime water milky. It turns into white in color. So the turning of lime water into milky is a standard test of carbon dioxide. So turning of lime water into milky shows that it contains carbon dioxide. If carbon dioxide is there, then it turns into milky color. That is a white color. Okay.